an AI infrastructure company. An infrastructure company that's essential all around the world. Every region, every industry, every company will build these infrastructures. And what are these infrastructure? These infrastructure, in fact, not unlike the first industrial revolution, when people realized, GE, Westinghouse, Siemens, realized that there was a new type of technology called electricity, and new infrastructure has to be built all around the world. And these infrastructure became essential part of social infrastructure. That infrastructure is now called electricity. Years later, this is during all of our generation, we realized there was a new type of infrastructure. And this new infrastructure was very conceptual, very hard to understand. And this infrastructure called information. This information infrastructure, the first time it was described, made no sense to anybody. But we now realized it is the internet. And every internet is everywhere. And everything is connected to it. Well, there's a new infrastructure now. This new infrastructure is built on top of the first two. And this new infrastructure is an infrastructure of intelligence. I know that right now, when we say there's an intelligence infrastructure, it makes no sense. But I promise you, in 10 years' time, you will look back and you will realize that AI has now integrated into everything. And in fact, we need AI everywhere. And every region, every industry, every country, every company, all needs AI. AI has now part of infrastructure. And this infrastructure, just like the internet, just like electricity, needs factories. Pick up a bottle. Of course you could imagine telling a robot to reach out and pick up the bottle. The AI capability today has the ability to do those things. Well, the computer that's where we're going in the near future. The computer that we're building to make this possible has properties that are very different than the previous. The revolutionary computer called Hopper came into the world about 3 years ago, and it revolutionized AI as we know it. It became probably the most popular, most well-known computer in the world. In the last several years, we've been working on a new computer to make it possible for us to do inference time scaling, or basically thinking incredibly fast. Because when you think, you're generating a lot of tokens in your head, if you will. You're generating a lot of thoughts, and you iterate in your brain before you produce the answer. So what used to be one-shot AI in the United States and around the world, everywhere I go, DeepSeek R1 has made a real impact on how people think about AI and how think about inference and how to think about reasoning AIs. They've made a great contribution to the industry and to the world. And so this is DeepSeek R1. The performance is 4 times the state-of-the-art H100. That kind of puts it in perspective, okay? And so if you're building enterprise AI, we now have a great server for you. We now have a great system for you. It's a computer you could run anything on. It's a computer that has incredible performance. And it, whether it's x86 or AI, all of it runs. Okay, our RTX Pro server is in volume production across all of our partners in the industry. This is likely the largest go-to market of any system we have ever taken to market. So thank you very much. And these factories are essentially what we build today. They're not data centers of the past, a $1 trillion industry providing information and storage, supporting all of our ERP systems and our employees. That's a data center of the past. This is similar in the sense that it came from the same industry. It came from all of us, but it's going to emerge as something completely different, completely separated from the world's data center. And these AI data centers, if you will, are improperly described. They are, in fact, AI factories. You apply energy to it, and it produces something incredibly valuable. And these things are called tokens. To the point where companies are starting to talk about how many tokens they produced last quarter and how many tokens they produced last month. Very soon, we'll be talking about how many tokens we produce, is now going to be thinking AI, reasoning AI, inference time scaling AI. And that's going to take a lot more computation. And so we created a new system called Grace Blackwell. Grace Blackwell does several things. It has the ability to scale up. Scale up means to turn what is a computer into a giant computer. Scale out is to take a computer and connect many of them together and let the work be done in many different computers. Scaling out is easy. Scaling up is incredibly hard. Building larger computers that is beyond the limits of semiconductor physics is insanely hard. And that's what Grace Blackwell does. Grace Blackwell broke just about everything. And all of you in the audience, many of you are partnering with us to build Grace Blackwell systems. I'm so happy to say that we're in full production, but we can also say it was incredibly challenging. Ecosystem in technology, in software, in industry has been the work of 3 years. This is a massive industrial investment. And now, we would like to make it possible for anybody who wants to build data centers. It could be a whole bunch of NVIDIA GB200s or 300s and accelerated computing systems from NVIDIA. It could be somebody else. And so today, we're announcing something very special. We're announcing NVIDIA NVLink Fusion. NVLink Fusion is so that you can build semi-custom AI infrastructure. Not just semi-custom chips, because those are the good old days. You want to build AI ecosystem of an AI supercomputer that I've shown you. Now maybe what you would like is you would like to use your own CPU. You've been building your own CPU for some time, and maybe your CPU has built a very large ecosystem, and you would like to integrate NVIDIA into your ecosystem. And now we make it possible for you to do that. You could do that by building your custom CPU. We provide you with our NVLink chip-to-chip interface into your ASIC. We connect it with NVLink chiplets, and now it connects and directly abuts into the Blackwell chips and our next generation Rubin chips. And again, it fits right into this ecosystem. This incredible body of work now becomes flexible and open for everybody to integrate into. And so your AI infrastructure could have some NVIDIA, a lot of yours. A lot of yours, and a lot of CPUs, a lot of ASICs, maybe a lot of NVIDIA GPUs as well. And so in any case, you have the benefit of using the NVLink infrastructure and the NVLink ecosystem, and it's connected perfectly to Spectrum-X. And all of that, is industrial strength and has the benefit of an enormous ecosystem of industrial partners who have already made it possible. So this is the NVLink Fusion. Whether you buy completely from us, that's fantastic. Nothing gives me more joy than when you buy everything from NVIDIA. I just want you guys to know that. But it gives me tremendous joy if you just buy something from NVIDIA. And so we have some great partners. L-Chip, Astera Labs, Marvell, and one of our great partners, MediaTek, Gigabyte, MSI, Lenovo. It'll be available from Box, from Lambda, amazing workstation companies. And this is going to be your own personal DGX supercomputer. This computer is the most performance you can possibly get out of a wall socket. You could put this in your kitchen, but just barely. If you put this in your kitchen and then somebody runs the microwave, I think that's the limit. And so this is the limit. This is the limit of what you can get out of a wall outlet. And this is a DGX station. The programming model of this and the giant systems that I showed you are the same. That's the amazing thing. One architecture, and this has the ability, enough capacity and performance to run a 1 trillion parameter AI model. Remember, Llama is Llama 70B. A 1 trillion parameter model is going to run wonderfully on the service. Digital chip designer, digital supply chain manager, digital versions, AI versions of all of the work that we used to do. And as I mentioned earlier, agentic AI has the ability to reason, use tools, work with other AIs. So in a lot of ways, these are digital workers. They're digital employees. The world has a shortage of labor. We have a shortage of workers. By 2030, by about 30 to 50 million shortage. It's actually limiting the world's ability to grow. And so now we have these digital agents that can work with us. 100% of NVIDIA software engineers now have digital agents working with them so that they can help them, assist them in developing better code and more productively. And so in the future, you're going to have this layer, that's our vision. You're going to have a layer of agentic AIs, AI agents. And so what's going to happen to the world? What's going to happen to enterprise? Whereas we have HR for human workers, we're going to have IT becoming the HR of digital workers. And so we have to create the necessary tools for today's IT industry, today's IT workers, to be able to manage, improve, evaluate a whole family of AI agents that are working inside their company. And so that's the vision of what we want to build. But first, we have to reinvent computing. Remember what I said. Enterprise IT works on x86. It runs traditional software, such as hypervisors from VMware or IBM Red Hat or Nutanix. It runs a whole bunch of classical applications. And we need to have computers that do the same thing while it adds this new capability. In the future, IT will have AI ops. And they will curate data, they'll fine-tune the models, they'll evaluate the models, guardrail the models, secure the models. And we have a whole bunch of libraries of models necessary to integrate into the AI ops ecosystem. We got great partners to help us do that, to take it to market for us. CrowdStrike is working with us. Data IQ is working with us. Data Robots is working with us. You could see these are all AI operations creating fine-tuning models and deploying models for agentic AI in enterprise. And you could see NVIDIA libraries and models integrated all over it. So Data Robots, here's Data Stacks. This is Elastic. I think I heard somewhere that they're downloaded 400 billion times. This is Nutanix. This is Red Hat. This is Trend Micro here in Taiwan. I think I saw Eva earlier. Okay, hi Eva. Because it is the only form of robot that can be deployed almost anywhere brownfield. It doesn't have to be greenfield. It could fit into the world we created. It could do the tasks that we made for ourselves. We engineered the world for ourselves, and now we could create a robot that fit into that world to help us. Now, the amazing thing about human robotics is not just the fact that if it worked, it could be quite versatile. It is likely the only robot that is likely to work. And the reason for that is because technology needs scale. Most of the robotic systems we've had so far are too low volume. And those low volume systems will never achieve the technology scale to get the flywheel going far enough, fast enough, so that we're willing to dedicate enough technology into it to make it better. But human or robot, it is likely to be the next multi-trillion-dollar industry. And the technology innovation is incredibly fast. And the consumption of computing and data centers, enormous. But this is one of those applications that needs 3 computers. One computer is an AI for learning. One computer is a simulation engine where the AI can learn how to be a robot in a virtual environment, and then also the deployment of it. Everything that moves will be robotic. As we put these robots into the factories, remember, the factories are also robotic. Today's factories are so incredibly complex. This is Delta's manufacturing line, and they're getting it ready for a robotic future. It is already robotics and software defined, and now in the future there will be robots working in it. In order for us to create robots and design robots that operate as a fleet, as a team, working together in a factory that is also robotic, we have to give it Omniverse to learn how to work together. And that digital twin, you now have a digital twin of the robot, you have a digital twin of all of the equipment, you're going to have digital twin of the factory. Those nested digital twins are going to be part of what Omniverse is able to do. This is Delta's digital twin. This is WeWin's digital twin. Now, while you're looking at this, if you look at it too closely, you think that it's in fact photographs. These are all digital twins. They're all simulations. They just look beautiful. The image just looks beautiful, but they're all digital twins. This is Pegatron's digital twin. This is Foxconn's digital twin. This is Gigabyte's digital twin. This is Quanta's. This is Wistron's. TSMC is building a digital twin of their next fab. And so, yes, Kaohsiung is a digital twin. Let's take a look at all of this.
Taiwan is pioneering software-defined manufacturing. TSMC, Foxconn, Wistron, Pegatron, Delta Electronics, Quanta, WeWin, and Gigabyte are developing digital twins on NVIDIA Omniverse for every step of the manufacturing process. TSMC with MedAI generate 3D layouts of an entire fab from 2D CAD and develop AI tools on COOPT that can simulate and optimize intricate piping systems across multiple floors, saving months of time. Quanta, Wistron, and Pegatron plan new facilities and production lines virtually.
Well, I want to thank all of you. I want to thank all of you for your partnership over the years. We are at a once-in-a-lifetime opportunity. It is not an understatement to say that the opportunity ahead of us is extraordinary. For the very first time in all of our time together, not only are we creating the next generation of IT, we've done that several times. From PC to internet to cloud to mobile cloud, we've done that several times. But this time, not only are we creating the next generation of IT, we are in fact creating a whole new industry. This whole new industry is going to expose us to giant opportunities ahead. I look forward to partnering with all of you on building AI factories, agents for enterprises, robots, all of you amazing partners building the ecosystem with us.